Hi everyone, welcome to Javaras. My name is Himanshu. In this video, we are going to create an auth to authorization server using Spring Authorization Server, and we will do some configuration so that we can use our project for production use case as well. So we will do a lot of customization like storing the users in the database and storing the clients and all the session information in the database. I have already created the project. There are some prerequisites. First of all, you should know how auth 2 works in general. So if you don't, then I have created a playlist. I will put the link to that playlist in the description. Also, you can go to these references, the Auth 2.1 authorization framework, and also you can go to Spring Authorization Server reference to understand what is Spring Authorization Server is, how you can get started. I have created one video as well where we are using Spring Authorization Server as an auth to authorization server. Now, in this video, we will go one step ahead and configure the authorization server for production use case. Now, for production, what you want generally is you want the users to be stored in the database. You want all the uh, clients to be stored in the database. You want users session information to be stored in some database, let's say some Redis cache. There are 4 or 5 components which we need to customize. So this is the main entry point for server application. So this is a configuration class, and this configuration class is importing different other configurations. So we have modularized configurations. The first thing which we want to focus on is this JWT config. Now you may know that authorization server exposes like 2 endpoints, user info endpoint, and the another one is like token introspection endpoint. And also, while generating a JWT token, authorization server needs something called private key, and corresponding public key is used while validating the token. Now, by default, whenever you restart your authorization server, then each time it will create a new private and public key and we'll use those. But we don't want that because in that case, if we have multiple instances of authorization server, then the access token created from one authorization server instance won't be valid for the second instance. And if you restart the authorization server, then the earlier created access token won't be validated if you send uh, a request to user info endpoint or token introspection endpoint. So what we need to do is we need to persist the private key, and using that private key, we need to generate public key and use those only. And that private key and public key should be persisted across different instances of the server or across restarts of the server. So let's say how we are doing it. If I go to JWT config, and then here, so the important thing is we need to expose this bean JWT decoder, which you will need to do whether you want to persist your private public key or not. Now this basically we are providing a bean which will decode the JWT token, and for this we need something called JWK source, and JWK source is created using private and public key. Now in the default implementation, if you just if you go here, let me go to Spring Authorization Servers documentation. If we just go here, getting started. So here as well, we are creating this JWK source. But here, when we are generating RSA key, so we are using RSA algorithm to generate this public and private key. Here we are generating a random private key. So whenever you restart the application, a new RSA key pair will get generated. But we don't want that. So what we need to do is we need to generate our private key like somewhere else. So For that, we can use something called OpenSSL, but it doesn't need to be this one. All we need is the private key. So OpenSSL can generate a private key. So we are using generate private key command here. This is the algorithm, and we will put the generated private key inside this file. So this is the file private key.pem. So make sure that you don't put this key in your version control system. And then we are giving some options. So we are generating key of this length, 2048 bits length. Once this is generated, then we want to put uh, this private key in environment variable. If you are using, let's say, Kubernetes to deploy your application, then uh, you can create a secret and you can use that secret here. So now this content of private key will be available as environment variable RSA private key in this container. So just suppose that this is the container where your auth server is running. Otherwise, if you are testing it in local, then you can export this environment variable using this command. So what it will do is it will read the content of this file. It will remove all these new lines, just that, and it will put the value in this RSA key file. So you can go to, and in this project, uh, I don't want to pollute environment variables of my system. So I use this .env file. Now there are some secrets in .env file. So I created .env.template, which I have put in version control system. So here you can see the RSA private key. So this will be the output of this command. So just run this command, whatever you get, put that here. So that will be value of RSA private key. Now we need to read this RSA private key, and using the private key, we can generate the public key. So now we have RSA private key public key pair, and we use that to decode the JOT tokens. So let me just go here again. So here what we are doing is in the generate RSA key, we are getting the private key content from this environment variable. So this private key starts with this text and ends with this text. So we are just deleting these texts and we are removing all the space characters. And this is base 64 encoded value of the private key bytes. So once we have this one, we are creating a key factory, and now we need to get the private key using this private key content. So here, first of all, we are base 64 decoding it, and then using PKCS at encoded key spec, we are generating a private key. Now we have a private key. So using the private key, we can generate the public key. So if we go to get public key here, we are creating public key using that private key and this key factory. Now we have this key pair, so we are just returning this public key private key pair. And so using that pair, so we are just extracting out private and public key, and we are creating this RSA key, which will be used by JWK set, and we are creating a JWK set here. So the private key will be used to sign the JWT, and private key will be used to validate that JWT, and the public key will be available to the public. So uh, so that anyone can validate the JWT token, but no one can change the JWT token because the signature needs to be from the private key, and private key is not accessible by anyone else. So that is it. So this is how we are doing this JWT config. So that was the first thing. Now the another thing is we need to store all the clients in the database. If you go here, this is the default implementation. So here we have something called registered client repository. So this is a repository for registered client. So registered client is nothing but a client which we register in the authorization server. So let's say in the GitHub, when you create a new application, so that is a new registered client. So we need to provide an implementation of registered client repository, and by default, it uses this in-memory registered client repository. Let's say you want to give clients the ability to register themselves, then you can't scale it because of uh, memory limitations. But if you store them in the database, let's say PostgreSQL database, then you can scale your application. Now let me show you how we have done that. Now the Spring Authorization Server already provides this implementation JDBC registered client repository. So we can just use that. It needs these JDBC operations which we can inject. Now for that we obviously need uh, the dependency to interact with the database. So we are using PostgreSQL database. Now if I go to build.gradle.kts, I can show you the dependencies. So first of all, we are using this Auth Authorization Server, and we are using this Spring Data JDBC, and we are using this Flyway as well for database migration. So using these, we will be able to connect to the PostgreSQL database, and we are using this runtime dependency here. Now for that, uh, now in order to store the clients in the database, we need some kind of schema. So that schema is also provided to us by the Spring Authorization Server. So if we go here somewhere here, yeah, these default DB schemas. So if I go here, so this is the schema which we need for clients, and there is this instruction for PostgreSQL or MySQL which you need to follow. For PostgreSQL, basically it tells that replace timestamp with timestamp tz to ensure the time instances are stored accurately. So basically time zone aware instance. Now, uh, so I have put that here in the resources db.migration is create client schema. So I have created this one here to store the clients. Then I created another schema or another migration to make this client ID unique. Because if you see in the client, we have ID, we have client ID, but client ID is not unique. But we need to ensure that client IDs are unique. So for that, I have added this new constant in the another migration script. Okay. And the application.yaml. Yeah, we have Spring data source, URL, username, and password, and these are coming from the environment variables. So if we go to env.template, you can see these are the variables which we need. And also in order to run the PostgreSQL, I am using Docker Compose. So if I go to compose.yml here, so this is Redis, which we will come to it later. Then this is the database, PostgreSQL database. So here we have these environment variables. This is the port and this is the volume. So I'm using this volume so that the data is persistent across different spin up of the PostgreSQL database. And here also we are injecting these environment variables. And Docker Compose can pick up environment variables from .env file. So, so these variables will work in Docker Compose file as well, or they can, or it can pick up from your system environments as well. So this is how we are using this one. And once you have this uh, Spring Data JDBC dependency and uh, these uh, uh, these configuration variables, then JDBC options is automatically created. If I go to client, yeah, so JDBC operations is all automatically injected, so you can use that. So your repository is valid or available there, whatever. Now let me go to authorization here. Sorry, let's go to security config. Another is user config. So we need to store the users in the database as well. So for that as well, uh, like Spring Security already provides this JDBC user details manager, which accepts data source. So data source is also automatically injected by Spring. So you can just use this implementation. And we are setting enable update password true. So what this means is, let's say some user has logged in a long back, and the password is still encoded in, let's say, SO256 uh, encoding, which is weak, but now the recommended is bcrypt. So whenever that user will log in the future, then its password encoding will automatically be updated. So I will show you that how it works. Then the next is authorization config. So authorization is not no in the authorization we need to see whenever authorization server generates your authorization code or access token, refresh token, ID token, these things, then by default these are stored in the memory, which is obviously limitation because you cannot scale up your application if there are a lot of users, then your memory will get filled up. Also, if you have multiple instances of the same authorization server, then the content of the memory is not shared. So if someone generated one access token from one instance, and if they try to verify it using the second instance, then it will fail. And and if you restart your server, then the earlier generated access tokens and everything will get lost. So you want to be able to see how many access tokens or which access tokens have been generated. And in JWT, it might not be a problem, but if let's say you are generating opaque tokens, and opaque tokens are always referenced to something which is in the database. So if it is not in the database, then uh, restarting of the server will automatically invalidate that token. So that is one thing. So for that, we are doing some configurations here. So this is the default configuration which we need for the authorization server, and so you can see that here in here. Okay. So this is the configuration which we need. Apart from that, this is the authorization service. So this is the responsible for saving and retrieving the authorization in the database. So by default, it is in-memory authorization service. So if you don't create any bean, but here we are creating a bean, and we are using JDBC Auth 2 authorization service, which is provided by Spring Authorization Server, and it needs two things: JDBC operations and registered client repository. So we are injecting both. And since we are already creating instance of registered client repository in this client config. Okay. Now let's see the schema of this as well. So this is also provided by Spring Authorization Server. This is schema, and this is the one here. Auth to authorization. This is the schema, and so there are some instructions for PostgreSQL, and so I followed them. Yeah, so we missed this one for users. In order to save users in the database as well, we need to provide this schema. So we need two tables: users and authorities. And this is also mentioned in the documentation of Spring Security. Now let's go to the consent. So uh, whenever a new token is generated, or whenever user provides consent for to any client, then a new entry is created in the consent. So consent basically means that this user has provided these many scopes or authorities to this client. Okay. So by default, this is also stored in the memory, but now we need to store it in the database. So we again use JDBC Auth to authorization consent service provided by the Spring Authorization Server, and this is the okay, yeah, this is the schema which we need, and I have, yeah, so I have registered this schema here. So this will be stored in the database. I think we have covered this JWT config. We have covered consent config. Also, we have covered authorization config. Okay, we have covered this authorization config, and yeah, this one as well. Okay. So that is one thing. Now let me go to README, because in the README I have mentioned the features. So Redis stores users, clients, generated tokens, and granted scopes in the PostgreSQL database. Yeah, and another thing is it stores the user session in Redis, because let's say some user is trying to is logged into our authorization server, and there are multiple instances. So what will happen is if they try to log in again. So ideally, what we want is if they are already logged in, then we just want to create the access token without them filling up their username and password again and again. But so this will work if the request goes to the same server. But if the request goes to another instance of the same server, then the session won't be available in that server for the user. So it will ask the user to log in again, or it won't know uh, uh, like at what stage the user is now. So this is a general problem. If you store the session in the memory, generally you should not store session in the memory. You should store it somewhere where it is persistent, but you can access it as quickly as possible. If you store it in the database, let's say PostgreSQL database, then there will be a problem because it will take some time to query the session from the database. But on the other hand, if you store it in the Redis, then querying from the Redis is much faster than querying from the PostgreSQL database. That's what we are going to do here. So for that, we need a few things. First of all, we need the Redis server. You can use whatever Redis server you want, but here we are spinning up Redis server using Docker Compose. So this is the Redis server, and this is also reading environment variables from .env file. And in the .env.template, I have already mentioned the configuration which is required, or the variables. So basically, you create .env file and put all these variables, but change their value according to uh, what you have. Now let's see what dependencies which we need. First of all, we need to be able to connect to the this Redis. So Spring already provides this mechanism that you can store all the user sessions in either Redis or JDBC. So for that, we just need this dependency, Spring Boot starter session data Redis, and you can see more about it here. Okay, so you just need this one dependency, and then you need a few configuration telling Spring how to connect to Redis, and we have done that. Put application.yml, Spring data Redis, host, port, username, and port password. So we have done all these things. Now the user session will be stored in the Redis. We don't need to do any other configuration. So we persist to the user session in Redis. Then persist user session generated tokens and granted scope across server restarts and across multiple instances. Now since we are persisting them in the uh, persistent persistent layers of the infrastructure, so these will be available across server restarts or across multiple instances of the server. Now the another thing which I want to talk about is ability to log in using GitHub. Our authorization server itself will be an auth to client of the GitHub. So GitHub will be authorization server, and our authorization server will be auth to client. So in this case, what we need is we need this dependency is Springboot starter auth to client. Okay, once we have this dependency, now we go to application.yml, and here is Spring security auth to client registration GitHub, and we provide client ID and client secret. I have already gone to GitHub and created this application. You can do that. Let me just quickly show you uh, how can you do that. Go to github.com and go to settings, go to developer settings, and here I have these apps. You can create a new GitHub app. If you go to security config, then there is one more thing which we did not cover authentication config. So authentication config determines how the user should be able to authenticate to our application. Okay. So if I go here, so this is the default configuration of this uh, Spring Authorization Server. So there we need to create two beans of type security filter chain. The first bean has order one, and this is only for authorization server. The second bean is that second bean determines how the user should be able to log in and uh, which endpoints they should have access publicly, which points should be restricted. Now let's look here. So here we have form login. We have configured form login as well, but we will go there later. We have this auth to login, and we are creating auth to login, and login page is auth login default success URL. So typically, if you just use like with default, so if you just do with default, it will work. Okay, but we have configured it this like this one. Okay, so now the auth to login will work. So I already have some video of how you can create auth to client using Spring Security Auth to client. So I can put the link in the description. Okay. The another is provides the ability to log in using one-time token and using custom configured pages for all kind of logging options. Okay. So basically, I want to cover all these three together. But for that, so it will be easy for me to explain these when we go through the demo of how this is working. Okay. So this is the terminal, and if I say docker ps, no container is running, but we already have this compose.yml file here. Let me zoom it in. I use a docker compose up d. Okay, then these are up. Also, what another thing I am doing is if you go to seeding, this is client seeder. So here I am implementing command line runner. So if you implement command line runner, then you need to implement this run method, which gets executed once the application startup is complete. So once it is complete, then I want to register this client. But for that, I am checking that if client one already exists in the database. If it does not, then we will create this client. Also, there is user seeder. This is doing the same thing, but it is creating two users if they are not present in the database. So that is it. But they are present. I have run it multiple times. Now let me go. I have this directory flows. Inside this one, I have authorization code grant flow. Okay. So you can use this one to test whether authorization code grant flow is working or not in your authorization server. So here I have hard coded a few things: auth endpoint, token endpoint, client ID, secret redirect to URI, and few things. And yeah, let me run this one. Flows. I will run this authorization code grant flow. So this generates this authentication URL. So let me just copy this one and I will open it here. It says this site can't be reached because this is not running. And in the env.template, you can create this one. Yeah, so if you see users this seeder, here I have created a component and profile seeding. So this bean will be available only when seeding profile is active. But by default, no profile is active. So what you can do is here, you can create one this variable spring profiles active equal to, and you can provide as many a list of profiles you want to be active. For example, local and seeding. So now these two profiles will be active, but these won't be because this is in .env.template. But in .env, I have put this variable. So these two profiles will be active. So see, if I restart the application, then at the starting, the following two profiles are active, local and seeding. But it won't seed anything because the client and users are already in the database. Okay, so I will just kill it. I will start it again and see, I copied it and I will paste that here. Okay, now you can see here we are using a customized login page. We are not using the default login page generated by the Spring because we need to customize that as well. So I have covered that as well here. Now how we are doing that? Let's look at that first. Right. So since this is related to authentication, so everything is present in authentication config. In the authentication config, right, let's look at form login. So form login is present. So login page is /auth/login. So whenever you change the login page, then uh, all other endpoints also gets changed. So for example, if you see here, we have /auth/login, and we are handling that here /h/login, and this is the default page, and we are returning this template which is present at auth login. If you go to templates auth, this is the login page login.html, and I'm using timely for it. So let's go to build.gradle.kts, and this is timely. So we need these two dependencies in order to use timely. Since I'm using timely, I can use timely templates here. Now here you can see what we are using. Uh, you can use param to read the query parameter. So if there is an error, then we will print this. If logout query parameter is present, then we will say you have been logged out successfully. And this is OTT sent, which we will explain later. Just for now, just focus on this one, this form. In this form, see, this will, whenever you click on submit or when you click on sign in, the request will be sent to /h/login with post method. By default, its value is /login. But since we have changed this one, since we have changed this login page, so all other things also gets changed. And we have default success and URL slash. So don't do this true. If you do true, then this means always use. So no matter uh, where you should go, the user will always go to the default page, which we don't want. Okay, because by default, after successfully logging in, the user should go to consent screen, or user should be redirected to somewhere else. But if nothing is provided, then it will go to the home page, which won't be true for authorization server most of the time. Okay, let's see. Okay, so yeah, that's all you need to do. You just need to send request here and tell it what should happen after successful login. If it is not successful, then also the user will be redirected to auth login with a query parameter error, which we will see. Okay, so that is it. So we need to send this username and password. Now let's see. So let's try to use Alice. I will use some wrong password. Click on sign in, and we can see invalid username or password. And you can see in the URL we have this query parameter error. So there have been some error. Now let me use the correct password, and let me open this one network. Okay, so I have done this. I don't want to use console. Yeah, let me click on sign in. Now we clicked on sign in. So I don't know why this like dot well known is specific. Okay, so what I will do is I will use Firefox because there is some problem with Fire this Chrome when you open DevTools it tries to redirect to somewhere else. So let me open Firefox and this one let me open a new private window. Okay, now we are getting this one. Inspect network. Alice and you can sign in. Okay, so you can see we are sending this request here, and TimeLeaf automatically inject the CSRF token because of this dependency. Because of this dependency, but you can manually as well inject this one. We are sending username and password, and we are getting the 302. So we are getting redirected here to the redirect URI, and in the redirect URI is for example.net, and here we have code. I can just copy it and paste it here, and now we got our access token back. Let me copy the access token, and now we can use this flow token introspection, paste the token, and we can see it is active. Okay, so that is how we are doing this form login and like customized form login. This is the login file which is C, and its CSS is present here, auth login.css, but that is not important to discuss right now. Now let's see how we are doing one-time token login. Okay, let's go to authentication config. So we have seen auth to login, and now I think you know why do we have this login page auth login, because whenever someone needs to be redirected for auth to login, they are not if they are not authenticated, and our authorization server wants them to be redirected using auth to, then they will be redirected here. Similarly for one-time login as well, login page is auth login. Now what happens is what is the flow of OTT? In the OTT, the uh, user is here in auth login page. So we will render our login page. There will be one box to enter their username. Or they click on like generate OTT or generate magic link, then Spring Security will generate OTT. But now we need to handle that OTT. What do we want to do with that OTT? Generally, we send that OTT to their email or their SMS. Okay. In that case, in this case, we are using this one console OTT generator. So we are just printing the OTT in the console. This flow again. I will go here. Okay. So we have. So this page doesn't look that great, but you can obviously customize it. Yeah. See, for password list, I will enter name. Let me enter Alice and click on send magic link. So as soon as I click here, the request goes to OTT generate, and we should see something in the console. In the console, we should see, yeah, here. This is the magic link, auth login OTT token. And if you see, the user was redirected to auth login OTT, but since there is no query parameter with the key token, so this is empty. So now there are two ways. Either you can go to this URL or you can copy this token and put that in the box. But I will just copy this URL and I will just visit this URL here, or I will visit the URL here only. See, now the token has been populated. Click on sign in, and you see after clicking on sign in, request went to the post request went to Auth1 login OTT, and with this CSRF token and this token, and this has been processed, and the user has been redirected to redirect URI. So you can copy this token, paste it here, and it is working. Now let's look at Auth2 as well. So we have seen Auth2, but let me quickly go through it again. For Auth2 login as well, we don't need anything else. We just specify the login page, default success URL, and we need to permit it. Another thing is we need to allow the request to these endpoints as well from anyone. Otherwise, user won't be able to log in at all. And also in the login.html, we have all these things like this is the form to login using username and password. This is form to login, passwordless login. I think yes. So this is for one-time token. So you can see this will send on OTT generate. Okay. So this is the default endpoint which is used to generate the OTT. You can customize this as well, but since this is not visible to user, so it's not necessary to customize it, but maybe you should customize it. Then this is important. So this is the button to log in using GitHub, and you should send the request here. Auth2 authorization and your registration ID. So this GitHub is coming from this one, this GitHub. So you can change it. So you can give it any name, but GitHub is, if you give it GitHub, then it is standard identity provider, which is already configured in the Spring Authorization Server, and you don't need to provide other details, but you can do whatever you want. And it will send the request here. And then the Spring Auth2 client will handle everything, which I won't cover. Okay, so let's see this in action. Right, let me do this again. Now, since this time I need to log in using GitHub, so I will just use this one, and I will close this one, or maybe not, because since I had previously already authorized this app to log in using GitHub, so I got this authorization code here, copy it, and I can paste it here, and that is it. Now, the last thing which I want to show you is how across server restarts as well, the state is persisted. So let's look at that. And along with that, we will also look at this thing. Docker PS, there are these two things are running. I will go to PostgreSQL and I will delete the database or things like that. So let's go there. Or so it is Docker exec it auth db bash PSQL, username is dev, then db name is auth db, password, and if you see dt, so these are the tables. Okay, so this is the user and many other things. So let's do this. I will say delete or let me do this. Let me change this one. Okay, and I will say update users set password equals to no and pass Bob, let's say, where username equal to Bob. Okay, now this is the password of the Bob. Also, let me do this. Select ID, client ID, and client secret from auth to registered client. So there is only one client. Now I want to change its client secret as well. So let me do that. I will say update auth to this one, set client to secret will be no auth and super secret. Where let's see whether this is same or not, because I don't want to change this at a lot of places. Yes, super secret. So I'm keeping the passwords and everything same, but like downgrading their password encoding. So I can show you how automatic password encoding update works, where client ID will be client one. Now, okay. Now this is done. So let me go here. Let me go to here. I will say authorization code grant flow. You copy it and I will just go here. Now we are here. Now at this moment, I will restart the server. I restarted the server, and if you see in the database, client is same, and then users are also the same. And if I log in with let's go, since we have restarted the server, but still session should be maintained. Click on sign in, and it is maintained. So we have been redirected to here. Now say why is it not asking for consent screen? Because consent is already persisted in the database. Okay. If we select start from users, see its password encoding has been changed to bcrypt. And there is this table, right? Auth to authorization consent. Select start from auth to authorization consent. See, Bob has already given this client these scopes. So if this client does not ask for any other scopes apart from these, then consent screen won't be shown. We can try that. Select or delete from auth to authorization consent. So it will delete everything. Now let me just do this. Okay. So if we try to go to here. Right. So we have seen that if we restart server here, it will work. See, now we are presented with the consent screen. Okay, so we could or we can customize this consent screen as well, and we should. But I will leave that as an exercise for you. But in my GitHub repository, you will find that I will customize this as well whenever I get time. Now we need to tick this profile or if we don't tick profile, click on submit consent, then in this case as well, we are getting this error access denied, right? Okay. So that is that. Now I want to show you one thing. Yeah, let's go here. So since we have not provided the required uh, scopes, so it failed. No, now let's go with one happy flow. Now we are getting this authorization code here. I will copy this one. If you see, these consents are here, and this is the access token. Now let me restart the server, and now I will copy this access token, and I will use token introspection, and you can see it is active. So uh, since we are persisting it in the database, so that's why it is working. It is still active. So that is it. That's all I wanted to cover. So the exercise for you is to customize the consent screen, and you should be able to find that in my GitHub repository as well in a few days. So with that, uh, I will end this video and I will meet you in the next one. Thank you for watching it. Bye.